How to implement selection sort in C# is an in-place sorting algorithm with a time complexity of big O of n squared and a space complexity of big O of 1, aka constant space. In selection sort, we swap the smallest element with the first element in an array. So we search the entire array before we swap the elements. Then we move our pointer to the second element in the array, and then we find the next smallest element in the array, and we swap that smallest element with the second position in the array. We continue this until we get to the end of the array, and then all elements will be sorted. Here's our example array. Here's the call to selection sort. Here's our method selection sort, taking an array of doubles. Here's an int min index to keep track of the index of the minimum value that we found searching through the rest of the array. And here's a double min value found to be used as a temporary variable for swapping later. So we start at the beginning of the array at index 0 and we go to the length of the array. We set our initial index as our initial min index, and then we look through the rest of the array, setting our remaining index or the beginning index of our inner loop to our main index plus 1, and then we go through the length of the array. So at the beginning our min index is 0, that correlates to the value of 10, and our first remaining index is 1, so main index plus 1, and that correlates to the value of 4, and since 4 is less than 10, we need to set our current min index to 1. Now we compare index 2 and 1. 8 is not less than 4, so we continue. Then we compare index 3 and 1. 6 is not less than 4, so we continue. Then we compare index 4 and 1. 7 is not less than 4, so we continue. We break out of that loop, and now we need to swap our values. So we have our min index at 1, which is the value of 4, and we put that in our minimum value temporary variable. And so our main index, 0, which is 10, will swap with 4. So we put 10 at our min index. And then we put our temporary value 4 in our min index 0. So now 4 is at 0 and 10 is at 1. Now our new main index will be at position 1 as we increment the outer loop. And then we will again go through the rest of the array looking for the smallest value, and we only swap when we find the smallest value and have gone through the entire array. We start at 10 and then we compare to position 2, position 3, we find 6 is the next smallest value, and we compare to position 7, and after we've went through the entire array we will switch position 3 with position 1, and so 6 will be at position 1 and then 10 will be at position 3. So now we have 4, 6, 8, 10, 7. So now we're at position 2, and we will look at the rest of the array, so positions 3 and 4, and we will find that 7 will need to be swapped with 2. So now 7 is at position 2, and 8 is at position 4. And we'll increment our loop, and we'll look at position 3. So we will look at 10, and we will compare to the rest of the list. So we look at 8, and we will swap 10 and 8. And now our list is sorted, and we will look at position 4 and 10 and compare to the rest of the list. There is no rest of the list, so we will return. Selection sort will have n squared comparisons no matter what the order of the numbers. So if they're in order, reverse order, or in some random order. So our worst case is big O of n squared, our average case is big theta of n squared, and our best case is big omega of n squared. And that's about it for the implementation of selection sort in C#. If you enjoyed this video, please give it a like and a comment below. If you'd like to see more videos like this, please subscribe to the channel. Thank you for watching.